Let's say you have a compound, for example, copper chloride, but you want the copper out of this, the metal out of this. What do? Well, for this, you can react this with a more reactive metal. For example, iron in this case. Now you might be wondering, Ram, how do I remember which metal is more reactive than the other? Well, for this, you will need a list of metals where they are ranked according to their reactivity, from most reactive to the least reactive metals. Now in this video, we are going to make this reactivity list and see how to use it, and more importantly, how to remember it. So let's begin. So to make this ranking list, I'm going to react metals with the salts of other metals. For example, let's take the salt of copper sulfate, and let's react this with iron. Now we notice over here that iron displaces or kicks out copper from its compound and finally forms iron sulfate instead. Now this means since iron was able to kick out copper, that iron has to be more reactive than copper. Let's confirm this by doing the opposite reaction. This time, let's take the salt of iron sulfate, and let's react this with copper. Now in this case, you would notice that no reaction happens. This does not go forward. Now this means that copper is not able to displace or kick out iron from its compound. This definitely proves that copper is less reactive than iron. Now let's look at one more example to solidify our understanding. Here this time I am reacting zinc with the salt of copper sulfate. And this time I notice that zinc also displaces copper and forms zinc sulfate. So here I would say that zinc is more reactive than copper. So technically, we are carrying out displacement reactions, and we are seeing that a more reactive metal is able to displace a less reactive one from its compound. So you can do this with different groups of metal. For example, over here, you can do the same reactions between iron and zinc and figure out which one is more reactive. And by doing so, we will be able to rank all the metals according to their reactivity. So we have already done the hard work, and we have ranked few of the metals according to their reactivity. So over here, the metals on top are more reactive than the metals on the bottom. For example, if you take magnesium is going to be more reactive than aluminium or iron or hydrogen copper. But since magnesium is below calcium and sodium, it is going to be less reactive in comparison to them. So this is how you read this particular list. Now let's see how to use them. For example, if you're given with a problem, hydrogen reacts with MgCl2. What are the products that are going to be formed in this reaction? So see, hydrogen is somewhere over here in the list, somewhere at the bottom, whereas magnesium is somewhere on the top. That means magnesium is more reactive than hydrogen. Hydrogen is less reactive here. And we know that a less reactive metal cannot displace a more reactive from its compound. That means this reaction is not going to proceed. There will be no reaction happening here. Let's take another example. Here iron is reacting with copper chloride. Can you pause the video and think about what are the products that will be formed here? Now if you have tried it, let's see. So iron is somewhere here and copper is somewhere below. That means iron is more reactive than copper. That means iron will displace copper from its compound. And finally we will get iron chloride plus copper. So here the reaction will go forward. So this is how you can use the reactivity series to predict the products of a chemical reaction. But this is not the only use case. See, one more important use case is that we depend a lot on pure metals. Okay, like iron and copper, you can find them quite often in your kitchen or electrical appliances or building materials. But you may not find these metals in their pure state in the nature. Meaning you might not find a rock of pure copper somewhere buried under the earth. You might find copper in combined state as a compound like copper chloride. And you will have to extract copper out of this. And for that, you will have to react copper chloride with a more reactive metal. And this information, like which metal is more reactive, you can get that by remembering or by knowing about the reactivity series. So reactivity series also helps us in extracting metals from their ores, and we'll talk about them in future videos. But now let's try to see how we can remember this long list. For this, I have a mnemonic, the careless zebra mnemonic. It goes something like this. Please stop calling me a careless zebra. Instead, try learning how copper mercury save gold. Now this helps me remember the order of the metals in the reactivity series. For example, with the first letter of please, I remember potassium. With the first letter of stop, I remember sodium. From cal of calling, I remember calcium, and so on and so forth. So you can also use the same mnemonic to remember these metals. Let's recall this one more time. Please stop calling me a careless zebra. Instead, try learning how copper mercury save gold. Now, one last thing is that this reactivity series might look slightly different than what you already have in your textbooks. Here you might find a couple of extra metals and carbon, which is a non-metal. And the reason is that carbon is something that we will deal with quite often. And that's why having it in the same list is very helpful for future. Okay, that's it for this video. Here we saw how displacement reaction can be used to figure out which metal is more reactive than the other. Here, the more reactive metal will displace a less reactive metal from its compound. And using this, we arranged few metals according to their reactivity. And we also saw how to remember this whole reactivity series.